Application of continuity law. So basically the flow rate is constant. So flow rate in the bottle jack example we've been working on is basically whatever you develop in the small piston, the same amount of liquid will go into the large piston. So the small piston total flow rate will be the exact same as the large piston flow rate. However, the total volume displaced will also be the same. However, the movement will be different here, because if you calculate the total volume displaced, so in this scenario it says that if the house, so this bottle jack is used to lift a corner of a house which is about 4,000 pounds, so it is lifting 4,000 pounds. The house corner needed to be lifted about 1 inch. So the total 1 inch cylinder, so you can, the total volume associated with that large piston is the area times the 1 inch of movement of the large piston. So that is 1 inch. So the area is pi by 4 d squared, 2.5 inches square times the 1 inch. So that will give us the total volume of the large piston needed to make 1 inch movement of that entire. So I calculated that is 4.91 inch cube of liquid you need to move that large piston 1 inch, this bottle jack. So this is the small piston right here, small piston, large piston. Now the question says every time you pump it goes down about 12 inch approximately. So this is 12 inch from here to, let's say, it's going down up to this. So you can compare this large triangle with this small triangle making here. We can calculate the height of the small piston movement if we move 12 inches down this handle. So for the large piston, so the small piston height changes h divided by the small piston, this distance 1 inch is equal to, you can write the large piston this movement, which is 12, and the total distance of this is 17, 1 plus 16. So the if you move the handle 12 is down, it's gonna make about this much amount of movement for the small piston. So every time you pump, let's calculate the volume displaced for the small piston per pumping stroke. So I'm gonna use this P to indicating that every time or maybe one here, that one stroke, you get the amount of volume displaced is pi by 4 times the diameter inches square times the height, which is 12 by 17 inch. So the total volume displacement, I calculated that 0.0499 inch cube. So every stroke this much volume is displaced by the small piston, and then same volume goes into the large piston, but the total volume we needed to pump is this much. Therefore the number of pumping required would be simply this divided by 0.049, which is approximately 98 pumping required to move the house up 1 inch by this, using this bottle jack. The second question is, so that's the answer to the first question. Second question is asking calculate the flow rate. It also says it moves every seconds that 12 inches down. So simply you can calculate the flow rate Q by using this small volume movement that is done in every second. It says that every second is gonna develop about this, displace about this much amount of fluid from this small piston. So then we'll convert that to gallon per minute. 231 inch cube is 1 gallon, and then 60 second is 1 inch, sorry, 60 seconds is 1 minute. So that will give us the gallon per minute. I calculated that 0.01296 gallon per minute. The next question is asking, is the fluid flow changes? No, because that's the continuity law. Whatever flow rate you are developing here, that's gonna go, fluid will go at the exact same rate in this piston. So Q small is same as the Q large.